The European Space Agency has just released the first images of 3 Atlas, and what they saw is unlike any comet ever recorded. In the blurry frame, the object takes up just 2 pixels, but those 2 pixels were enough to stun the astronomical community. It was ejecting gas so violently, it created a CO2 cloud the size of the distance between the Earth and the Moon. Yet its trajectory remained almost completely unchanged. ESA scientists are calling this the most challenging observation in the history of the Mars orbiter. While across the Atlantic, NASA has gone silent. Why? At the very moment ESA released its data, did all of NASA's communication channels go dark? And in those 2 blurry pixels, what did they really see? The story begins with a daring decision. On October 7, 2025, the European Space Agency pointed the CASIS camera, an instrument on the ExoMars Trace gas orbiter, out into deep space. That might sound routine, until you realize CASIS was built to look down at the Martian surface from a few hundred kilometers away. Not to hunt for faint specks in the darkness between stars. This time, CASIS was aimed at a target 10,000 to 100,000 times dimmer than what it normally photographs. From a staggering 18.6 million miles away from Mars, Nick Thomas, the principal investigator for CASIS, admitted it was an incredibly difficult observation. But it's in these impossible moments that we get the chance to see what no one has ever seen before. In the resulting image, 3 Atlas swells to fill just 2 pixels, a tiny, dot-like glow. Yet it holds a storm of contradictions. The comet's head, or coma, measured by CASIS, was only about 680 miles across. That's suspiciously small compared to earlier observations from the Hubble Space Telescope, which had measured the same glow at 4,000 miles wide. Was the object shrinking? Was it losing material? The answer, according to ESA, was no. The difference simply revealed the limits of the instruments. Hubble, with its massive mirror, could see the faint, outer wisps of gas. CASIS, optimized for bright planetary surfaces, was only sensitive enough to detect the dense, brilliant core. In other words, CASIS wasn't seeing less. It was seeing the core more clearly. And it was in that core that 3I Atlas began to reveal its strangeness. Its brightness was uneven. Its center reflected more light than predicted. And it showed signs of directional jets of gas, a rare feature for a comet. With just 2 pixels of data, ESA had painted the first picture of a traveler that was both familiar and alien. It looked like a comet, but it moved as if it understood its own propulsion, just as ESA released its data. NASA, with its far more powerful instruments, fell silent, crippled by a government shutdown, as one agency was forced to power down. The other captured the impossible. The story suddenly gained a new layer of drama. How many other discoveries have we missed? Simply because we weren't looking at the right place at the right time. But this was only the beginning. Behind those 2 faint pixels, the numbers describing the mass, density, and behavior of 3I Atlas were about to force the scientific world to rewrite the definition of a comet. Only a few days later, observatories worldwide began releasing numbers that left astronomers speechless. The estimated mass, over 33 billion tons, more than 1,000 times heavier than the average comet, and 330,000 times more massive than Oumuamua. Its nucleus was 3 to 5 miles wide, remarkably small for its mass, which meant its density had to be incredibly high, approaching that of solid rock or metal. Meanwhile, its behavior defied all known laws. A normal comet, when it ejects gas, creates a natural thrust that visibly alters its orbit. This is called non-gravitational acceleration. But 3I Atlas didn't budge. It remained as stable as a colossal steel sphere. Each day, the force of its jets barely shifted its path by less than 50 feet. A change so small it was almost zero. What does this mean? Either the outgassing was too weak to matter, which was ruled out by its massive CO2 tail, or the object's mass was too enormous to be affected. According to Newton's laws, if the force F is constant, but the acceleration A is nearly zero, the mass M must be extraordinarily large. This thing was absurdly heavy. For comparison, a typical comet is like a porous, fragile, dirty snowball, But 3I Atlas behaved like a dense, metallic boulder highly reflective, yet completely unmoved by its own jets. Some researchers began to joke, half seriously, if this is a comet, it's a comet designed by aliens to fly straight. But the anomalies didn't stop there. When polarimeters measured the light reflecting off it, they returned a value of 2.77%. This was an extremely low reading, never before seen in any comet. It suggested the dust particles surrounding 3I Atlas had a completely bizarre shape and composition. Perhaps they were jagged, or perhaps they were artificial. A massive, dense, abnormally reflective object that fires jets but doesn't move. It was breaking the laws of physics with perfect precision. After the world debated its impossible mass, ESA dropped an even more startling piece of data. Its chemical composition was completely wrong for a comet. The first light spectra sent back showed no familiar signs of water ice or carbon monoxide, the chemicals that dominate most comets. Instead, researchers found an unusually high concentration of CO2, packed tightly around the nucleus, as if the object was wrapped in its own thick, stable, and unnervingly personal atmosphere. But what stunned scientists wasn't that it had CO2, but how the CO2 existed instead of diffusing freely. The gas appeared to be shooting out in narrow, targeted jets, a sign of a non-uniform surface with active hotspots. On a normal comet, this might suggest natural vents. But here, the angles of the jets were too regular, their rhythm too stable. It looked regulated. Then came the metal spectra. ESA's Omega and Spicum instruments detected the spectral line for nickel, but not for iron. In nature, nickel and iron are cosmic twins. They are forged together in the hearts of stars and are almost never found apart. Finding nickel without iron is like finding a coin with only one side, if the results were correct. It pointed to a physical process never seen before, or worse, a deliberate metallurgical process. By now, 3I Atlas was no longer just a wandering rock. It had become a chemical black box, containing alien materials and exhibiting behavior that could not be attributed to nature. Even the most cautious scientists were forced to admit if this was a comet. It was formed in an environment completely different from any star system we know, or by a hand that knew exactly what it was doing. If the chemical signals made scientists question the origin of 3I Atlas, its orbit made every natural explanation even harder to swallow. An object randomly thrown from interstellar space should, statistically, enter our solar system from a random direction, at any angle relative to the ecliptic plane, the flat disk where the planets orbit the sun. But not 3I Atlas. Its trajectory was almost perfectly parallel to this plane, with an inclination of just 4.889 degrees. The number was so small that celestial dynamicists had to run the calculation 3 times to be sure it wasn't a software bug. According to models, the probability of an interstellar object falling so precisely into Earth's orbital plane is less than 1%. If it was random, it was a perfect fluke. Even more, when they traced its path, they realized 3I Atlas wasn't just hurtling straight through. It was gliding in, as if visiting each planet, passing Mars, approaching Venus, and then heading toward the sun. It was a path so refined it looked less like the result of blind gravity and more like a pre-calculated journey. Skeptics were quick to jump in. There's no proof it has an engine. True, but there's also no proof it doesn't, for an object with immense mass, high density, and almost no orbital deviation from its own jets like 3I Atlas. Any small, subtle push would be enough to change its direction without being detected. An ancient probe could travel like this for millions of years, using the gravity of planets for natural boosts, arriving exactly where it intended, just like the trajectory we are witnessing now. Then there was another strange detail. Its direction of travel originated from a patch of sky within 9 degrees of where the WOW-A signal was detected in 1977. A radio burst so powerful that for nearly half a century, no one has been able to explain it. A coincidence, perhaps. But add that to the perfect orbital angle, the stable trajectory, and an arrival timed for optimal observation, and the picture starts to look too perfect to be lucky. From a faint speck of light, 3 Atlas was now forcing us to question not only what it's made of, but the very intention behind its path. When ESA published its complete data set, the scientific community split in two. One half looked at the flawless trajectory of 3I Atlas and declared, "This cannot be random." The other half scrambled to find a natural cause. From this divide, two major theories emerged, both so audacious that, if true, would rewrite the history of astronomy. The first came from Dr. Suzanne Falsner, an astrophysicist specializing in planet formation. She called 3 Atlas a planetary seed, a fragment of ancient matter that wandered between stars, carrying enough mass and solidity to trigger planet formation in young, dusty star systems. In her view, the universe could operate like a giant garden, where seeds like this drift through space, sowing new worlds. If 3 Atlas is a seed, its arrival isn't an accident, but part of a natural cosmic cycle where star systems regularly exchange material, like wind carrying pollen from one region to another. It's a beautiful, poetic, and hopeful theory. On the other side, however, Professor Avi Loeb looked at the exact same data and saw something completely different. He argued that 3I Atlas was not a seed, but a fossilized machine, the relic of an ancient technology that once crossed the void between stars. Loeb pointed out that everything about it was too precise: its immense yet stable mass, its highly reflective surface, its unusual materials, and its nearly calculated orbit. Nature isn't that optimized, he stated, but engineering can be, for him. 3I Atlas could be an observation device, or a form of physical signal sent in place of a radio wave, a silent way of communicating across eons. These two theories, one romantic, one chilling, stand in direct opposition. Yet both are based on the same hard data. They don't contradict the facts, only the way we choose to see the universe. Either we believe this is a wondrous natural phenomenon, proof of the cosmos's infinite creativity, or we accept that somewhere out there, another civilization got here first. A long, long time ago. All debates must eventually bow to reality. For 3I Atlas, that reality is approaching at over 134,000 miles per hour in a few weeks. On October 30th, 2025, it will reach its closest point to the Sun, a mere 60 million miles away, even closer than the orbit of Venus. And that will be the ultimate test. If this is just an ordinary comet, the Sun's immense heat and tidal forces will tear it to pieces. But if it survives intact, every theory we have, from its mass and structure to its origin, will have to be rewritten. ESA, NASA, and hundreds of observatories around the world are preparing for that moment. The JWST is scheduled to turn its lens toward the Sun to watch, while ground-based telescopes will track it from just before dawn. They all want to answer the same question: will this thing break apart? And if it doesn't, what will we even call it? The latest orbital simulations show that the surface of 3I Atlas will endure temperatures exceeding 400 degrees, 750 degrees Celsius, hot enough to vaporize every volatile compound, including carbon dioxide. A normal comet wouldn't last more than a few hours under those conditions. But if 3I Atlas is made of the dense, solid material the data suggests, it could pass through the fire and continue its journey outward, an immortal rock blazing through the flames. Some scientists have even prepared 2 press releases. If it breaks up, ESA will announce an analysis of the debris to determine its true composition. But if it survives, they will have to find a new word to describe it, because we will no longer be talking about a comet, but about an unprecedented interstellar object. Whatever the outcome, 3 Atlas has already achieved something incredible. It has forced humanity to rethink its understanding of the universe. A tiny object, from a nameless place, has made hundreds of scientists put their theories aside, just to wait and see whether it will dissolve in the light or walk through it without a scratch. If you want to follow this journey with us to see what happens when it passes the Sun, and whether it survives or disintegrates, subscribe, so you don't miss the next chapter. Because if something is coming from between the stars, we'll be the first to tell its story.